Viewers, welcome to my new YouTube channel. This channel is dedicated for all SHS students who are very serious in learning physics. The inspiration behind this channel was got from a student from Tamale Senior High School. Her name is Saida Rahman. Apologies if I cannot mention your name well, Saida Rahman, but you are the inspiration behind this channel. It's dedicated for students to bring their problems in physics for us to solve together. Please subscribe, click on the notification bell, like, and comment. Saida's request is on dimensional analysis. Deriving equations among quantities using dimensional analysis is one of the easiest things to do. Let's take the first problem. If we're solving problems, we just teach us the way to do it. And as we practice, we become perfect. There are so many equations in physics, some of which we may not remember, but then we can use dimensional analysis to derive that equation when we forget. Or as we study a system in physics, we can also use dimensional analysis to derive certain equations, even if we have not come across that equation before. Let's take this question. The period t of a simple pendulum depends on the length L and acceleration due to gravity g. Establish an equation among t, L, and g using dimensional analysis. The first thing to do when we get a problem of this sort is to write a proportionality expression over here. According to the question or the instruction, the period t, we are told, depends on, so that means it's proportional to certain quantities, L, the length, let's put it down, and then the g, which is acceleration due to gravity. But there is something we must do here. We don't know the proportionality power of the L and the G. It could be L to the power something, which could be negative or positive, G to the power something. We don't know. So for that matter, we introduce some arbitrary. We can use X for the L, and then G, we can use Y for that. So T is proportional to L to a certain power that we don't know. It can turn out to be power half, which will then be a square root. So we don't know the power dependence. So G to the power Y. That's the first thing to do. Somebody who has come across simple pendulum before knows the equation for the period that depends on the L and the G. In fact, T is equal to 2 pi square root of L over G. But then, how do we derive that over here? So, the next thing to write is T. Remove the proportionality sign, bring an equal to. Then you bring a proportionality constant K, which is dimensionless. It could be 2, it can be 2 pi, it could be 3, it could be any number at all. But it doesn't have any dimension. So L to the power X, G to the power Y. That is the second step. The third step is to write the dimensions for all the quantities, with the exception of the dimensionless K. So the period T is already a basic quantity. So its dimension is the same, capital T. It's time is equal to K. L is also a fundamental quantity. So L to the power X. G is a derived quantity. And its dimension, of course, is acceleration, which is distance or displacement divided by time squared. So we have times L T to the power negative 2 all to the power y. So LT to the power negative 2 stands for this acceleration. That is a unit for, in fact, that is a dimension for the acceleration, all to the power y. Next step, if there is any bracket, expand it. Then use the powers of indices to add or to subtract. So we have t is equal to, we have k, l to the power x here. Then we expand the bracket, we have l to the power y, t to the power negative 2y. So we have some like bases over here. We can add the exponents because they are multiplying. So we have t is equal to k, l to the power x plus y, then t to the power negative 2y. L is a different dimension, t is a different dimension. So we cannot add all of them. We need to add only this. And this will be a separate quantity. So where we have reached, we are going to compare exponent, comparing exponent. And in comparing exponent, we first have to compare the exponent of the quantities that are on the left and on the right. Or we have to be smart to compare exponents. And the first that we have to compare should be an exponent that will give us a straightforward answer. So here, let's not compare L, the powers of L first, because it contains x and y. But if we check t, t only contains y. Okay, so comparing the exponent of t, this t is to the power 1, this is to the power negative 2y. So 1 is equal to negative 2y. I got that from the t. For that matter, y is equal to negative half. That's a straightforward answer. We have gotten y. And let's write an equation in terms of the exponent of L. L doesn't have any similar quantity to the left. So we equate the powers to 0. In fact, it has it over here, but it is to the power 0. And any number to the power 0 is 1. That's why we don't write this one. So x plus y should be equated to 0. So then x plus y is equal to 0. So what is y? Y is negative half. So x minus half is equal to 0. And x is equal to half. So having got the exponent, we put it back into the original equation here. That is the second step. Permit me to write that sort of here. So we have t is equal to k l to the power x, and x is positive half, and then g to the power y, y is negative half. This can be written as t is equal to k l to the power half divided by g to the power half. To turn this negative half into positive, just reciprocate it. That's a simple arithmetic. So the follow-up equation will be t is equal to k, the squared root of l over g. Why am I getting the squared root of l over g? Now l to the power half is square root of l. G to the power half is square root of g. And then combining those two square roots, we have one straight square root for both of them. And is a final answer. So as demanded from the instructions here. So the period of oscillation of a simple pendulum is dependent on the L, the length of the string, and G, acceleration due to gravity. And in fact, if you study the simple pendulum as a separate system, you would know this dimensionless constant. It is 2 pi. 2 pi. So 2 pi square root of L over G. But in dimensional analysis, you don't need to know the exact value for K. So just leave your answer this way. T is equal to K square root of L over G. This is a solution to our first problem, and you need to go step by step. First, proportionality constant, then the powers will appear on top of each of the quantities. Bring an equal to, introduce a proportionality constant, and of course, bring your dimensions. If there is any expansion you have to do it. Then compare exponent, find the powers, slot it back into the second equation, and then do what you are supposed to do. Let's look at the second problem. Stay tuned. This is a new physics channel for SHS students who are serious to solving problematic questions they get. The inspiration behind this channel was from a serious student from Tamasco. Her name is Saida Rahma. Now she requested for this. That's why I'm starting with her. Kudos, Saida, and be free to ask any question and to contribute on the channel. Stay tuned. Our second problem is that the force F acting on a conical pendulum depends on the mass m, the velocity v, and the radius r of the horizontal circle described. Derive an equation among F, m, v, and r using dimensional analysis. So the first thing to do is don't panic. It is a very simple thing to do. Now, a conical pendulum is also a special pendulum where a mass attached to a string is whirled around and it defines a horizontal circle. Now, the force on that pendulum depends on several quantities. We have the mass of the object or of the pendulum, we have the velocity, we have the radius, then we have, so the mass v and r. So derive an equation among these ones. First step, we are saying the F depends on, so proportional to 1, mass m to the power x. We don't know the proportionality power dependence, so let's introduce a power for the m. Velocity v to the power y. It could be to the power anything, but we have chosen xy. And then r. Let's use z for the r. The follow-up equation is F is equal to, introduce a proportionality constant, K. The dimension for M is capital M, of course to the power X. The dimension for V is Lt to the power negative 1, all to the power Y. So the dimension of V is Lt to the power negative 1, which is displacement over time, and over time means t to the power negative 1. So this represents the dimension for v, so all to the power y. And the dimension for r is l, so to the power z. Now, if you want to portray a thorough step-by-step solution, there is one equation I have just skipped. That equation is, so before this, you can choose to write this. What I mean is, the dimension of force, which is represented by this square bracket, is equal to a proportionality constant times the dimension of the mass, which is m, to the power x, times the dimension of the v to the power y, times the dimension of the r to the power z. This is what I skipped. So I skipped this and just wrote F is equal to K. Dimension of M is capital M to the power x. The dimension of V is Lt to the power negative 1, all to the power y. And the dimension of R is L to the power z. So the dimension of F is mass times acceleration, which is m L t to the power negative 2. So I skip this equation, but it doesn't matter if you bring it. In fact, this is better than the initial one. So after writing the proportionality sign, just introduce your dimensions on each of the quantities to the power their exponent, and afterwards bring their dimensions. So this square bracket is kind of a symbol that the next equation you are bringing in the dimensions of the quantities. So for the force, you have mLT to the power -2 is equal to, K is dimensionless, capital Mx. Dimension of V is this one to the power y, and then for R is L to the power Z. Expand brackets and use indices to add exponent. So you have mL T minus 2, which is the dimension for force. That one you must know. Knowing force is equal to mass times acceleration, you need to be able to know the dimension of force. No one will give that to you. You have to know. It's equal to K M to the power X. Expanding the bracket, we have L to the power Y, T to the power -y, L to the power Z. So mL T minus 2 is equal to K M to the power X. We have like bases over here. Let's add the exponent. L to the power Y plus Z, then T to the power -y. So comparing exponents, we first compare the exponent, which will give us a straightforward answer. So if you check through, let's see the exponent of m. It is only x. So let's start with that one. Comparing the exponent of m, we have x is equal to, we have a counterpart here, m. It is to the power 1 is equal to 1. So m to the power x is equal to m to the power 1. Therefore, x is equal to 1. That is very cool. M gives us x equal to 1. That's very cool. The next thing we can compare will be t. T has only y, -y. So in that case, -y is equal to -2. Therefore, y is equal to 2. That is very cool. The last thing is comparing the exponent of L. For the L, y plus z is equal to 1. We know y to be 2. What is z? So 2 plus z is equal to 1. And therefore, z is equal to 1 minus 2, which is -1. So our exponents are 1, 2, and -1. So let's go back to this equation. That says that f is equal to, let's remove the dimensions. We don't need it anymore. It's equal to k m to the power x. But x is 1, so m to the power 1. We don't write that. V to the power y. What is y? Y is 2. R to the power z. What is z? -1. Let's rearrange. We have f is equal to k mv squared r to the power -1. We reciprocate that and make it positive. So over r. And that is the final answer. That f is equal to k mv squared over r. And in fact, the proportionality constant k, it turns out to be 1. That one is when you study the system using Newton's second law of motion, F is equal to ma. The real equation will turn out that the proportionality constant is 1. So F is equal to mv squared over r. But then in dimensional analysis, it has to be written like this way, k. You don't need to know beforehand that it should be 1 or 2 pi or 3. Just leave your answer this way, as I have said. I'll close the episode with a trial question and submit your answer through WhatsApp or DM me any platform you'd like to send your answer. Stay tuned. So I end the episode with this trial question to Saida Rahman and all other serious physics students who would like to join the channel. And the trial question goes: the frequency F of a vibrating string depends on the length of the string, which is L, the tension T, and the mass per unit length mu. Derive an equation among the frequency F, the length L, the tension T, and the mass per unit length mu using dimensional analysis. There is a hint I need to give you. Frequency is a reciprocal of the period. You need to know that. Of course, L is a simple quantity. Tension T is a force, and you have to know the dimension for force. The mu is a mass per unit length. Mass per length. You have to also get that one. Good luck to all the students on the platform, especially to Saida Rahma, the inspiration behind this channel. Please kindly subscribe, click on the notification bell, comment, and then share among friends. Stay tuned.